Engineering is not just about making something work, it's about making it work efficiently. When we build battery powered products, most people focus only on hardware. Choosing low powered components matters, but hardware alone doesn't give you the flexibility. Firmware does. Let me show you what I mean by that. Here is an example of a simple real-time monitoring project, right? So I've got an ESP32 microcontroller, which is basically reading an LDR sensor. The microcontroller is using the value to control the load, the LED. This whole setup works in a very simple code. So this is an example. So all we do is define the pin and obviously read the change in resistance from the LDR, and we can use that value as a threshold and we can turn the LED on or off, right? It's a very simple code. Once we upload this code, it seems to be working. So it's the LED is turned on. So if we flick this, the LED turns off, which is resistance value decreases. And when it goes into darkness, the resistance value increases. So hence the light turns on. Next thing we're going to measure is we're going to use a multimeter and see how much power or how much current this module draws in order to execute this code and turn on and off this LED. So I've connected the multimeter in series with the source. So we can see this module, the microcontroller, is driving around 45.3 milliamps, so which is quite high, right? So if we go and look at the datasheet of this module, it actually runs at 240 megahertz, which is incredibly fast. The real question that we need to ask ourselves is, and do we need this microcontroller running at full processing power? Probably not, because all we're doing is a very minimal task. So here is what we can do to save some battery power. So we're going to look at three particular ways. The first one, since we looked at our microcontroller runs at 240 megahertz and we can reduce the processing power. With this particular module, the lowest we can have is at 80 megahertz, and we're going to reduce the CPU frequency to 80 megahertz. And secondly, what we can do is, since we're not using any Bluetooth and Wi-Fi function, we can simply disable them, and that will help to save a bit of power as well. And lastly, we can put this module into a light sleep mode between the readings. So now if we upload this code, then I'm going to show you, you'll be very surprised how much power we'll be saving just doing that. Now if we look across our multimeter, look at that, it's roughly about 5 milliamps. We made this system about 9 or 10 times better than it was before. It's basically the same hardware, just a smarter firmware. So with adding few lines in our code, we made this system almost 10 times better. Can you believe that?